find H bar at minus 3, 4, 0 due to the current filament shown in figure. Okay. So this red color line, whatever is there, that is the current filament. So you can see that this is consisting of two semi-infinite lines. Okay. One is this, it is ending here, but the other ending point is infinite, at infinity. And the second semi-infinite line is this. It's starting here, but it's ending at infinity. Okay. And you have to find out what is the magnetic field at this point. So first we will write down what is the expression for the magnetic field because of a finite current carrying conductor, finite length current carrying conductor. Okay. So what is that? It is given by I by 4 pi r cos alpha 2 minus cos alpha 1. And what about the direction? Direction is going to be a phi bar or minus a phi bar depending on the current direction. We will take first one conductor. Okay, this conductor we will take. Okay, and we will find the magnetic field first due to this conductor. Okay, so let us name this as conductor 1 and this as conductor 2. So H1 bar will be only due to the conductor 1. Okay, due to semi-infinite conductor 1. So we will have to find out what is R, what is alpha 2 and what is alpha 1. So for that we will draw this semi-infinite conductor separately again. Okay, so this is the starting point. What is the point here? 0, 0, 0, origin, right? And the point where we want to find out the magnetic field is minus 3, 4, 0. Okay. So this is perpendicular because both the points, they are lying on the xy plane and the current carrying conductor is along the z axis. So z axis is perpendicular to the xy plane. So this is the perpendicular distance. So if you find out this distance, then that is nothing but r. Okay. And what about alpha 1 and alpha 2? So you have to join the end points of the conductor. So here this is alpha 1, which is 90 degrees. Okay. And what about alpha 2? This tends to 0 degrees for an infinite length. Okay. So now we have the values of alpha 1, alpha 2 as well as r. Okay. So you are going to get H1 bar is equal to, I is given as 3 amperes. So 3 by 4 pi into r is root over minus 3 minus 0 whole square plus 4 minus 0 whole square plus 0 square. Okay. This is 4 pi r. Next is cos alpha 2, which is 1. So you can write 1 here, minus 0. Then what about the direction? So if you apply the right hand rule here, you can see that the direction, if you see from the top of the xy plane, it is going to be in this direction, clockwise direction. Okay. So you can write here minus a phi bar. But we want the answer in the xy coordinates. Okay. So a phi bar is not enough, we need in the xy coordinates. So how do we do that? So if you can see here, this direction is a rho cap. Okay. And this is the direction that we got. So this minus a phi cap we will take as some x cap. Okay, it has some ax component, x bar component, some y bar component. Okay, and some z bar component. Z bar component is anyway 0 because it is lying in the xy plane. Okay, this is 0 because a phi is in xy plane. Okay. So from here a rho dot, this is phi. Okay, a rho dot minus a phi is equal to 0, the cross product, because they are both perpendicular. So we know the radial vector. Okay, once we know the position of the point, what is the point? Point is minus 3, 4, 0. Okay, then what is the position vector to this point? The unit vector, unit position vector, it is nothing but minus 3 ax cap plus 4 ay cap plus 0 divided by root over 3 square plus 4 square, which is 5, dot x ax cap plus y ay cap is equal to 0. So this from here you are going to get minus 3x plus 4y is equal to 0, or 3x is equal to 4y. Okay. So if you take this equal to some parameter, so there will be infinite solutions to this, right? So you can take it as an parameter. So from here you are going to get x is equal to t by 3 and y is equal to t by 4. So now we need the unit vector. Okay. So a phi cap you can write as t by 3 ax cap plus t by 4 ay cap divided by the magnitude t by 3 whole square plus t by 4 whole square. So in this way t is going to get cancelled and you are going to get the final expression 4 by 5 ax cap plus 3 by 5 ay cap. Okay. So in this manner you can get the tangential direction, okay, in terms of the x and y coordinates. So h1 bar magnitude we have found here, okay, and the direction also we have found. So if you combine both, then h1 bar you are going to get as 38.2 ax cap plus 28.65 ay cap. This is in milliampere per meter. Remember, there is a 10 to the power minus 3 term here. Okay, so this is due to conductor 1. Next we have due to conductor 2. This is conductor 2. So let us redraw that conductor 2. This is the x, y and z, and this is the conductor here. And where is the point? So if you extend this x axis, this is the point minus 3 comma 4 comma 0. Okay. So now we need to find out, this is one angle and this is the other angle. Okay. So now here this angle is going to be alpha 1 because P is towards the other side, and this angle is going to be alpha 2. Alpha 2 anyways it will tend to 0 because it is an infinite line. Okay. But you have to find out what is alpha 1. Okay. So if you just redraw only this part, right, this is the negative x axis, this is the origin point, and here you have minus 3, 4 and 0. So this is alpha 1. So if you drop a perpendicular here, okay, so this is nothing but the x coordinate, which is 3, right, mod x is 3, and this is nothing but the y coordinate, which is 4. So this angle, this length is going to be 5. So from here you can directly write down what cos alpha 1, this is going to be 3 by 5. Okay. So now we can write down h2 bar, this is equal to I by 4 pi r cos alpha 2 minus cos alpha 1. Then what will be the direction here? So if this is the x axis, the current direction is given like this, right, this is the 3 amperes. Now at this point if you apply the right hand rule, then the current direction is tangential, but it will be perpendicular, that is in the direction of the z axis at this point. Okay. So you can directly write here, this is a z cap. Okay. And what about the distance? The distance r is going to be nothing but the perpendicular distance from the line. Okay. So what is the perpendicular distance? It is nothing but the y coordinate, which is 4. Here we have already taken, this is 4. Okay. So we have now r is 4, I is 3, 3 by 4 pi into 4. What is cos alpha 2? Cos 0 is 1 minus cos alpha 1 is 3 by 5 az cap. Okay. So the final answer you are going to get 23.87 az cap milliampere per meter. Okay. So now what is the complete magnetic field because of both the conductors 1 and 2? H bar is simply going to be the vector sum of h1 bar and h2 bar. Okay. So this is going to be 38.2 ax bar plus 28.65 ay bar plus 23.87 az bar. Okay. So this is the final expression. Two planes z is equal to 0 and z is equal to 4 carry current k bar is equal to minus 10 ax bar and k bar is equal to plus 10 ax bar respectively. Okay. So determine the h bar at these 2 points. Okay. So we'll first see what is this planes z is equal to 0 and z is equal to 4. So z is equal to 0 basically means that all points on the plane, they should be having the z coordinate 0. So that means there is nothing but the xy plane, right? All along the xy plane, the z coordinate is going to be 0. So this is the z is equal to 0 plane. Now where is z is equal to 4? It will be parallel to the xy plane, but at coordinate z is equal to 4. Okay. So you can draw from the side view like this. Okay. This is the z is equal to 0 plane and this is equal to, this is the z is equal to 4 plane. Okay. So this is the direction of the z axis. Now if you consider the first point 1, 1, 1, if you see the z coordinate, right, we want the z coordinate here because that will give us the idea about where the point is with respect to both these planes. Okay. So z coordinate is 1 implies that it will be in between these two planes because as z is equal to 0, z is equal to 4. So 1 should be somewhere in between. Okay. So you can, this is the first one. So this point somewhere here you can write 1, 1, 1. Okay. So now if you consider this as the plane 1 and this as plane 2. Okay. So what will be the magnetic field intensity only due to the infinite sheet 1? So this is, we have already derived half into the current density k bar cross the unit normal vector. Okay. So unit normal vector of plane 1. So a n1 cap you can take. So for this plane, the point is here. So what will be the normal vector direction? It will be in this side, right? So what is this side? It is minus az bar. So a n1 cap is nothing but minus az cap. Okay. So now we can write here h1 bar is equal to 1 by 2 into what is the current density of the first one of the z is equal to 4 plane. Z is equal to 4, z is equal to 0 is minus 10 ax bar and z is equal to 4 is plus 10 ax cap. Okay. So you can write here k is 10 ax cap cross a n1 is minus az cap. Okay. So x cross minus z, you are going to get ay plus ay. Okay. So this is 5 ay cap. Similarly, what is h2 bar? This is 1 by 2 k bar into a n2 cap. Okay. So what is the unit normal vector here? For this plane z is equal to 0 plane, the normal vector is in this direction, that is the plus z direction. Okay. So here a n2 cap is equal to plus az cap. Okay. And what about the current density? For z is equal to 0 plane, z is equal to 0 plane minus 10 ax cap. Okay. So here you are going to get 1 by 2 minus 10 ax cap into az cap. Okay. So this is minus ax cross az, that also is going to be plus ay cap. Okay. So 5 ay cap. So what will be the total magnetic field intensity? The vector sum of h1 bar and h2 bar. So this is going to be 10 ay cap. Now if you take the second point, what is the second point here? It is 0, minus 3, 10. Okay, so 10, z coordinate is 10, so it will be above both these planes. Okay, so we can redraw the planes here. This is z is equal to 4 plane and this is z is equal to 0 plane, and the point we want is here 0 comma minus 3 comma 10. Okay, so if this is the first one and this is the second plane, then this is the normal vector a n1 cap, right, and this is the normal vector to the second plane. Okay, because for both of these planes the point is now above. Okay, so both of them will be equal to az cap plus az cap. Okay, so what is h1 bar? This is going to be 1 by 2 k bar cross a n1 cap. So this is equal to 1 by 2 10 ax cap into az cap. Okay, so this you are going to get minus 5 ay cap, and similarly h2 bar is equal to 1 by 2 minus 10 ax cap into az cap. Okay, so x cross z is minus 5, so here minus is there, so it should be total final answer is going to be plus 5 ay cap. So then what will be the total magnetic field intensity? h1 bar plus h2 bar is equal to 0. Given the magnetic vector potential A bar is equal to minus rho square by 4 az cap Weber per meter. Now calculate the total magnetic flux crossing the surface. Phi is equal to pi by 2, 1 less than or equal to rho less than or equal to 2 meter, and 0 less than or equal to z less than or equal to 5 meter. So here what we have is the magnetic vector potential, and we need to find out the magnetic flux crossing through the surface. Okay, so phi is equal to integral b bar dot ds bar. Okay, so we need to find this b bar. This can be found from the vector magnetic potential A bar, and ds bar from the given information, right? This is the given information, different parameter values are given. Okay, so from there we have to find the surface. What is the surface? So first we will see what is the magnetic flux density. This is the curl of the vector magnetic potential. Okay, so if you can see here rho, phi and z, that means it is a cylindrical coordinates. Okay, so we have to find out the curl in the cylindrical coordinates. So what is that expression? Here outside you will have 1 by rho. Okay, so all these formula for different coordinate systems we have already discussed. Just refer if you have not, if you don't remember it. Okay, so 1 by rho, a rho cap, a phi cap, here it is accompanied by rho, and finally you have az cap. Okay, and d by dou rho, dou by dou phi, dou by dou z, and the last row is going to be a rho, rho a phi, and finally a z. So what are these? These are the components, right? This is the rho component, a rho component, a phi component and a z component. Okay, so from the given information what do we have? Except az, these both are 0, right? Because what is a bar? A bar is minus rho square by 4 az cap. Okay, so that means only the az component is present. So this is 0 and this is 0. So here you are going to get 1 by rho, a rho bar, a rho cap, dou az by dou phi. So that is 0 because az does not have any phi component. Okay, so that is 0, minus dou by dou a phi by dou z. So that is anyway 0. Here it is 0. Okay, so first component is 0, minus rho a phi cap. Now here if you can see dou az by dou rho is not 0. So we can write here dou az by dou rho. Okay, the other thing is 0 because this is 0. So this into this is 0, plus az cap. this is 0, this is 0. Okay, so this is the only expression. Okay, so if you differentiate it, then the final expression that you're going to get is 1 by 2 rho A phi cap. So now we have the magnetic field density B bar. Now next thing we have to find what? We have to find what is the surface. Okay, so if you can see here, this phi is pi by 2, 1 is less than or equal to rho less than or equal to 2 meters, and z is varying from 0 to 5. So if you can draw the coordinates here, this is the x axis, this is y axis, and this is z axis. Okay, now the phi is given as pi by 2. Okay, so that means this along the y axis, right? Phi is this direction, so pi by 2 will be somewhere on the y axis. Okay, so on the y axis again, what is the rho? Rho is varying from 1 to 2. So we will take the rho varying from 1 to 2. Rho is equal to 1, rho is equal to 2. Okay, and again z is varying from 0 to 5. Okay, so this is z is equal to 0, this is at the origin, z is equal to 5 is this. Okay, now the same thing you should extend it for the z is equal to 0 to z is equal to 5 coordinates. Okay, so you are going to get this rectangle. Okay, this is the required surface area. Okay, so now you can see that this surface, it is going to be perpendicular to which vector? The A phi bar vector. Okay, so the magnetic flux is also in the A phi bar direction. So B bar dot ds bar we can write as 1 by 2 rho A phi cap dot, see here the surface vector is having the normal vector as A phi cap, right? A phi cap is the normal vector. Okay, so when this is the case, then the other two will become the differential elements, the other two coordinates. Okay, so what are the other two coordinates? Rho and z. Okay, so rho and z, they are not accompanied by any other parameter. So we have the elementary area as dou rho d rho dz A phi cap. So the dot product is going to give you 1 by 2 rho d rho dz. So now we want the flux integral 1 by 2 rho d rho dz. Okay, so rho and z are independent here, so we can integrate independently. What is the variation of rho? It is from 1 to 2, z is varying from 0 to 5. Okay, so this you are going to get as rho square from 1 to 2 into z from 0 to 5. Okay, so the final answer you are going to get 3.75 Webers. This is the total flux passing through the surface. Next question, a charged particle moves with a uniform velocity 4 ax cap meter per second in a region where E bar is equal to 20 ay cap volt per meter and B bar is equal to B naught Ez cap Weber per meter square. Determine B naught such that the velocity of the particle remains constant. Okay, so now when does the velocity remain constant? Velocity is remaining constant implies that the acceleration is 0. Okay, so velocity is equal to constant implies acceleration is equal to 0. When acceleration is 0, it means the force acting on it, the net force acting on it is equal to 0. Okay, so when there is an electric field as well as a magnetic field, what will be the force here? This is going to be Q into E bar, this is the electrostatic force, plus Q into V bar cross B bar, right? What is V bar here? This is the velocity. So that is also given. So we have E bar, V bar as well as B bar. Okay, we don't have Q, but we don't need it because see, the net force is 0, that means F bar should be equal to 0. So here we can write 0 is equal to Q, you can take out common, E bar plus V bar cross B bar. Okay. So Q, we can take it to the other side. The final expression that you're going to get is E bar plus V bar cross B bar is equal to 0. Okay. So if you substitute the E bar, what is E bar value? It is 20 AY cap plus V bar is given as 4 AX cap cross B naught AZ cap. This is equal to 0. Okay. Now X cross Z, what will it be? It is going to be minus AY cap. So here you can get 20 AY cap minus 4 B naught AY cap is equal to 0. So when will this be 0? When B naught is equal to 20 by 4, which is equal to 5. Okay. So this is the value of B naught for which the force experienced by the particle will be 0, and if force experienced is 0, then it is going to have a uniform velocity, constant velocity.